Okay, so 4.2, day 2.
Yeah.
We need to fill in these points around here.
Yeah.
Now, last week we spent some time with 30, 60, 90, 45, 45, 90, and I told you those were important things, right? So I'm going to show you some more interesting stuff about these. So right here is a 30-degree angle, yes?
Yeah.
So if you drew this imaginary line, if you want to, if you drew this imaginary line here, what kind of a triangle did I make?
Right.
A right triangle that happens to be a what triangle?
30, 60, 90.
30, 60, 90. What is the ratio across from 30 degrees?
1.
1. So if this is 30 degrees, what angle is this?
That's 6.
That's 60. What's the ratio across from 60?
Square root of 3.
Square root of 3.
The
Now-
SPLA members going to the elementary.
Just wait a second.
Report down to the included
Wait,
room.
1 second.
Kids, baby.
Okay, so
SPLA members that are going
this
to the elementary,
point
please report
right
down
here,
to
yes?
the-
Yeah.
Its coordinate is xy. What is the x? What is the x? Square root of 3. What is the y? 1. What is the r?
What?
1 square root of 3,
That would be
2. Yes? Now remember, this circle is full of ratios, yes? So if I make my radius 2, and I come out here and do 2, but I do x over r, which would be 2 over 2, you'd still get what? 1. So I didn't lie to you, did I? So this is my x, this is my y. If I want cosine, all I have to do is put it over what? The radius. So it's square root of 3 over what? 2. That's the cosine at 30 degrees. The sine is y. What's the y? 1. What's the radius?
2.
So what is the sine at 30 degrees? A half. You see that?
Cosine is 2.
The cosine, nope, the cosine is square root of 3 over 2.
Oh, wait, no, I meant like whatever the opposite one is.
For the cosecant? Yes, the
that one.
cosecant would be 2. That is correct. Okay, I will continue to record. Yep. Okay, so we did 30 degrees, yes?
Yep.
Is there another angle on here that is 30 degrees away from the x-axis?
Opposite side.
150, yes? Okay, so 150 is 30 degrees. So what imaginary triangle do I have here?
Right.
A right triangle, which is a 30, 60, 90. Okay, what is my point over here then? Negative square root of 3, 1. Okay, why is the square root of 3 negative?
Because it's on the negative side.
Because it's a negative side.
I have a question. Would the square root turn into 3i?
No, it's a negative outside.
Okay.
It's not imaginary. Okay, is there another 30-degree angle?
210.
210 is another 30, 60, 90 triangle.
Yeah.
So what is my coordinate there?
Negative
3
square root of 3, negative 1.
Negative square root of 3, negative 1. Now you guys are picking up, it seems like, on the negatives. Why are they negative?
Because they're on
down.
It's on the negative sides of the coordinate plane, right?
Yeah.
Okay, so then, is there another one?
330.
330. So what is the coordinates on 330 going to be?
Square root of 3, negative 1.
Square root of 3, negative 1. Now, if I want the cosine, I look at the x, yes? And I throw a 2 underneath, because that's the hypotenuse, right?
Yeah.
Okay, so the cosine of the absolute value of the cosine for 30, 150, 210, and 330 is all square root of 3 over 2. Yes?
Yeah.
And then you just have to decide what quadrant they're in to know if it's negative or not. Make sense? So when I told you that you had that big chart to do, did that big chart get a little smaller?
Yeah.
Yeah, because as long as you know that angle is 30 degrees away from the x-axis, Do you know the sine and the cosine?
Yeah.
Yes. It's called the reference angle. Okay? The reference angle is the distance from the x-axis. So any angle that has a reference angle of 30 degrees will have square root of 3 over 2 for cosine and 1/2 for sine. And then you'll just have to decide what quadrant it is to figure out whether it's positive or negative.
So
Make sense?
for 45 it'd be a little.
Okay, so 45, let's move up to 45 then.
That was,
That's just 30 we did.
Yeah.
So again, I'm drawing this imaginary triangle.
It's gonna be a 45, 45, 90.
It's going to be a 45, 45, 90 triangle.
Hypotenuse is 2.
The hypotenuse is 2 again because we're going to stick with that 2, right?
the
And
fourth
both legs are
square root of 2.
square root of 2. That's why I'm color coordinating so you can see. So that means my x and my y are what?
Square root of 2.
Square root of 2. So is the sine and cosine the same?
Yes.
Yes. So the sine and cosine for 45 is square root of 2 over 2.
wait, why is the y?
Because on a 45, both legs are the same. They're both square root of 2.
Yeah.
Make sense?
Yeah,
Austin, do you have a question?
you said you still do the divided by 2.
Yeah, right now it's just an x and a y.
Okay.
If I want the cosine, I put it over 2. If I want the sine, I put it over 2. So right now they're x and y. There are some of these, you can find these unit circles out there, and they will have this coordinate as square root of 2 over 2 and square root of 2 over 2, but it doesn't say x, y. It says cosine and sine. Because once you put it over the radius, then it is the cosine and sine, not the x and the y anymore.
So tangent is just the sine over cosine.
Right, or square root of 2 over square root of 2, which is 1. Okay? So what other angle?
135.
135, because 135 is
45.
45 away. So what's my point over here?
Negative square root of 2, square root of 2.
Negative square root of 2, square root of 2. What other one?
225.
Wouldn't it be negative square root of 2, 2? Square root of 2?
On 225?
No, for 135.
Negative
It's the x is the x
square root
is
of 2.
Negative
square root of 2, square root of 2. The x is negative.
I didn't.
So on 225, what's the difference?
They're both
negative.
They're both negative. And again, why are they both negative?
Because
They're
it's
opposite of the
quadrant.
Right. The third quadrant and both x and y are negative.
315.
So 315,
Square root of 2, negative square root of 2.
square root of 2, negative square root of 2. Now, guys, anytime, this is so funny because every time I go, what's the reference angle? And it has to be 30, 60, 45, or a quadrantal because we're working on that. And I'll say, what's the reference angle? And it ends in a 5, and they're like, If the angle ends with a 5, and I'm expecting you
45.
it's going to be 45, right?
Yeah.
You just got to figure out what quadrant you're in to figure out,
Yeah.
right? So I'm like, don't overthink that. Don't. Okay.
Yeah, we're thinking
Last one we have is what?
A 60 degree.
A 60, 30, 90. So
Which wouldn't be the
it
same
just
thing.
switched places, yes?
Mhm.
So now my x is 1 and my y is
Square root of 3.
square root of 3. So my point is
1 square root of 3.
1 square root of 3. So what other angle?
120.
120. Again, because 120 is 60 away from 180, right?
Yep.
So negative 1 square root of 3.
Yep. 240.
And 240 is going to be
Negative 1, negative square root of 3.
negative 1, negative square root of 3.
And then 300.
It's 1 negative square root of 3.
So again, guys, this is for you to use to check your answers. but I expect you to be able to do these. Okay? And we will move into that more tomorrow. We're going to take the triangles out of the circle, and that's when I really show you how to do it efficiently. Okay? But your assignment today a lot is working with this. So as soon as you can start doing that, the better, making a connection with the triangles. So you have your circle out in front of you, so I'm going to switch back to the PowerPoint. Sound good?
Hey.
I thought that was gonna be way more confusing than it was.
No. It just references where you're at. Okay, so we just got done finishing this, right? And you have it. Again, it's a reference, not a crutch. It's not there for you to look up every single answer. By tomorrow, you should be trying to find the answer on your own and then checking it. Got it?
Yeah.
Okay. Tonight, you might be looking at it all the time unless you like, ooh, I think I got the pattern. Then go for it. Okay. So how we're going to use it is you should already know that if it has a reference angle of 30, the denominator is going to be 6, right? Because 30 goes into 180 how many times? 6. If it has a reference angle of 45, the denominator is going to be what? 4. Because 4 goes into 180 how many times? 4. Or 45 goes 180. If the reference angle is 60, the denominator is going to be what? 3. Because the 60 goes into 180 3 times. If it ends in a 2 or a whole, it's a quadrantal, right? If the denominator is a 2, it's on the y-axis. If it's a whole pi, it's on the x-axis, right?
What was a quadrantal again?
90, 180, 270, they make the quadrants.
Oh.
Okay, so evaluate the 6 trig functions for the given angles. This is what the majority of your homework is. So after yesterday, do you all know cosine is x over r, sine is y over r? Like you wrote that down enough yesterday, you got it? Okay, if you still don't have it, you need to write it down. Okay? So we have sine of pi over 6. Now we have an angle now, right? Okay, sine is y. Pi over 6 is 30. What's the y on 30?
Y on 30? 1.
1. Okay, and what's your r? Always 2. That's it. So if we just did sine, what one do we want to pair with sine?
Cosecant.
Cosecant.
Yes,
So the cosecant of pi over 6 is the reciprocal, which would be r over y. So it would be 2 over 1 or just 2. And I don't know, I always start with sine for some weird reason. Some people like to start with cosine because we start with x a lot on things, but... Okay, so cosine is x. What is the x at pi over 6? Square root of 3. And r is always 2. Now, guys, I can put any 30, 60, 90 triangle in there, anyone. And when I take away that scalar on the sides, the ratios are going to come down to 1 square root of 3, 2. It doesn't matter, okay? So if it is a 30, 60, 90 right triangle, it doesn't matter what the side lengths are. These are the ratios. Okay?
So even if it was like, instead of it being 1, 0, what if it was 2, 0? Would that be...
So then our hypotenuse would be 4. But when we reduced everything down, it would come down to 1 square root of 3, 2.
Okay.
Yep. Okay, so what function goes with cosine?
SEC.
Secant. Secant of pi over 6 is the reciprocal.
You'd have to multiply the top and the bottom by square root of 4.
Yes, I do have to rationalize that. I can't leave it 2 over the square root of 3. I have to multiply both by the square root of 3. So that gives me 2 square root of 3 over 3. And I will take off for not rationalizing.
Guess we gotta do tangent now.
Yep, we gotta do tangent. So tangent of pi over 6 is y over r. So y is 1.
Wait,
Not r, y over x. Sorry.
so it's square root of 3 over.
It's, no,
1 over square.
1
You're rational.
over the square root of 3.
Rationalize.
So then I have to rationalize it. And what would I get when I rationalize it?
Square root of 3 over 3.
Square root of 3 over 3.
And then cotangent.
And then cotangent. Now, don't, here's a hint, guys. If you had to rationalize tangent, don't reciprocate your final answer. Go back to your what? First answer.
The unrational.
Right. So cotangent is x over y. Well, the x was square root of 3, right?
And the y was 1.
And the y was 1, so
square root of 3.
square root of 3.
I had a question on the cosine. Wouldn't it be 2 over 2 instead of 2 over 1? Because the rational is 2.
On the cosecant right here?
No. Yeah.
Right here?
Yeah.
Okay, it's just, it's 1/2. So the reciprocal 1/2
Oh,
would,
wait, I was looking at the wrong thing. My bad.
okay. I was like, oh, you had me scared.
Wait, for the next one, the sign would be 0 over 2.
No. No. Okay.
0 over
No. This. Okay. Pi is a quadrantal angle, yes? Okay. So pi is over here.
Yep.
What's my coordinate over there?
Negative 1, 0.
So I have -1, 0. Yes?
Yeah.
Okay. Now, it was the radius, if you think about the rest of them, was 2, right? So when I took 2 and divided by 2, I get 1. They've already done. Okay, since this is a unit circle, it's a circle of ratios. So all I'm going to use is my x and my y. That's it. Okay? So, because we've already done the division. We've already done the division of the radius.
So if it was.
Okay, so if, we'll do it this time. Okay, so if I got the circle, and I just got done doing all of these, and this was 2, yes? So this point right here, actually this point right here, would be -2, 0, correct?
Mm-hmm.
Okay, so you guys ready then? We'll do the long way, and then we'll do my short way. So the sine of pi would be y over r, right?
Mm-hmm.
So 0 over 2, which would be what? 0. I'm following? The cosecant of pi would be 2 over 0, which would be
0.
undefined. You can't divide by 0.
What if, oh, wait, never mind.
Everyone good so far? The cosine of pi would be 2 over 2, negative 2 over 2, which would be what?
-1.
-1. The secant, am I going too fast? Of pi would be 2 over -2. Radius can never be negative, which would be what? -1.
And
Tangent would be what?
Y over X.
So y over x. So 0 over -2, which would be what? 0. And cotangent
Undefined.
would be 2. That should not have been a negative. Yeah, that should be. It should be -2. Sorry. It would be -2 over 0, which would be undefined. Now, what I was trying to get through to you was the unit circle is a circle of ratios, yes? And we already said this point right here was negative 1, 0, because we already did the division by 2. And if I just did this, now watch really quick, sine is y, right? What's the y over here? 0? So 0. What's the reciprocal of 0? Undefined. The reciprocal of 0 is undefined. What's the reciprocal of undefined? 0. Okay, cosine is x, yes? What's the x?
Negative 1.
-1. Reciprocal of -1 would be
Negative
-1.
I have a question. Where did you get the x and y? Like,
The unit circle.
It's our unit here. Our unit here was 2, so this would be -2, 0. Like, that's the radius.
no, like, I'm not seeing, the only place I'm seeing pi is 180.
Yes.
And that's what we're solving for. Because t equals what?
Right here at this point. Right here at this point was that -2, 0. So I was using that to show you how you could just do the 1, 0.
Why is it at 2, 0?
Because what was our radius for 30, 60, 90, 45, 45, and 60, 30, 90? It was 2. Yes?
Yeah.
Okay, so Ethan was asking why wasn't our radius still 2? And I was showing him our radius is 2, but when we take 2 divided by 2, we get what? 1. We get our unit circle. Okay, our unit is a ratio. Our unit in this circle is 2, but 2 divided by 2 is what? 1. So all you have to do is look at your x and y. You don't have to put it over r. On the quadrantal angles, you don't have to put it over r. It's already done for you. Okay, so tangent would be y over x, yes?
Yeah.
So 0 over -1 would still be what? 0. And -1 over 0 would be undefined. So on the quadrantal angles, the x over r has already been done for you. Okay, 5 pi over 4. Okay, so looking at your circle, 5 pi over 4, you should know it's a 45, right?
Yeah.
Okay, 5 is 1 more than 4, so that's in the third quadrant. See how I'm all doing this, and I'm not even looking at this. So the third quadrant, x and y are both negative, aren't they? So sine and cosine and secant and cosecant are all going to be negative, but tangent is going to be what? Positive? Because both the x and y are negative, so it's going to be a positive. Okay, so we've already said it's going to be negative. Guess what I do before I even start? I put the negatives. You know why I put the negatives? So I don't mess them up. How about cotangent instead of cosine twice? Okay, so sine is your y. What is your y at 5 pi over 4?
It's negative square root of 2.
Okay, so it's a negative square root of 2 over what?
Square root
Oh, no, 2.
of 2. No, or 4.
2.
2.
So then cosecant, I reciprocate that, right? So I have 2 over square root of 2. So I have to rationalize it. So it gives me negative 2 square root of 2 over 2. Does it simplify?
Yes.
So I get negative
Square root of 2.
square root of 2. Do you see why you're going to want to remember that rather than do it all? Make sure it's charging because that alternates between your two rows. Okay. So then, guys, what do we know about any 45? What do we know about the sine and the cosine?
They're gonna be the exact same.
They're exactly the same, aren't they? So what is the sine of 5 pi over 4?
Negative square root of 2 over 2.
Negative square root of 2 over 2. And what is the secant at 5 pi over 4 then going to be?
Negative square root of 2.
Negative square root of 2. I didn't have to go through all that again because I did. Does everyone understand how we got to negative square root of 2? No? Okay, so let's go through it again. Okay, so we're going to reciprocate 2 over negative square root of 2, right? So I have to multiply by that square root of 2 because I can't leave it in the denominator. So numerator and denominator. So I get 2 square root of 2 over negative 2. And then my 2's reduce, and I'm left with negative square root of 2. Good now? Okay. Now, it's going to be negative square root of 2 over negative square root of 2.
So multiply by negative square root of 2.
No, they're just 1. They're the same.
I did the long way.
Oh, yeah. If you did one, good for you. But it's just 1. They're the same, right? And what's the reciprocal of 1?
1.
1. Okay, so now we have t is negative pi over 3. Now, the sine of negative pi over 3 is going to be equal to the sine of, look on your circle, if I go negative pi over 3, what positive angle am I the same as?
60 degrees.
No, on your circle, go negative pi over 3, which is 60 degrees, yes?
Yeah.
So go negative 60 degrees, and in radian, what angle do you end up at?
240.
No.
Negative. Maybe 120.
If I go negative 60 degrees, don't I end up at 5 pi over 3 or 300?
I said 300.
You said 300?
I said 300.
Yeah, you did.
Oh, I'm sorry. But do you see that?
Yeah.
Okay, so we got to stay in radians because they gave me in radians. So now I just took a negative angle and made it the positive angle, and they're the same.
Explain that one more time, please. How you
Okay,
did that.
so I'm going negative pi over 3.
Mhm.
Yes, which is the same as 60. So if you drop down negative pi over 3, 300 is coterminal with negative pi over 3. Do you see that? Okay, so when we have coterminal angles, their sine, cosine, tangent, cosecant, all that are the same. They're the same.
Even if it's on the other side.
It doesn't matter. The position, the terminal ray is in exactly the same position. They're the same. Okay? So then, what is my x?
So you want to use 5 pi over 3.
Yep, we're going to use 5 pi over 3. Which is actually going to be the same as pi over 3, but then with our positive and negatives, which we'll worry about that later, but not now.
So 1 negative square root of 3.
So 1 negative square root of 3 is my point.
So negative.
So if I just wrote that down, I could do it, right? So negative square root of 3 over 2. And where'd you get the 2 from?
The radius.
The radius. Okay. And then we've got cosecant. Of negative pi over 3, but it's the same as 5 pi over 3. And so that's going to be negative 2 over the square root of 3. But when we rationalize it, 2 square root of 3 over 3. Cosine of negative pi over 3. What's your x?
1,
1. So 1 over
2,
2. Secant.
be 2.
Oops. Yes, it would be 2. I'm trying to hurry to get through this example. And tangent
Negative.
would be what?
Negative square root of 3 over.
Negative square root of 3 over 1.
Or just negative square root.
negative square root of 3. And cotangent of negative pi over 3
Rationalize.
would be 1 over negative square root of 3. So negative square root of 3 over 3. I know we went kind of fast on that.
Yeah.
But we're just using our what? Our x and our y?
Yeah.
Yep. And remember to take a negative angle and find its positive, and it will be easier to do, and then we'll make it even easier after that. And I think, am I good, Isaiah?
Yeah, you
Okay, I want to see how far. Okay, I just had more, and we got to 1 negative. So negative 5 pi over 6, you'd find the positive angle.
On the other side.
Yep, all I had were more examples.
Okay.
If you get to domain and range problems, do not worry